Welcome back, everyone. In today's video, we're delving into the second significant section of Generative AI and LLMs for Dummies by David Baum. Before we get started, make sure to hit that like button, subscribe to our channel for more in-depth explanations on complex topics, and don't forget to leave your comments and questions below. The building blocks of Generative AI. Generative AI is built on neural networks and profound learning models. These models consist of layers of interconnected nodes that process input data and learn patterns through training. The more data these models are exposed to, the better they become at generating accurate and relevant content. The structure of the human brain inspires neural networks. They consist of neurons, nodes, connected by synapses, edges, which process and transmit information. In a neural network, data is passed through multiple layers of neurons, with each layer learning to recognize different features of the input data. This hierarchical learning process enables the network to capture complex patterns and relationships in the data. The role of transformers. Transformers represent a significant breakthrough in the field of NLP. Unlike previous models, transformers use mechanisms like attention to process and generate text more efficiently. This allows them to handle long-range dependencies in text and generate high-quality outputs. Attention mechanisms allow transformers to focus on different parts of the input data when generating outputs. This enables them to capture relationships between words and phrases far apart in the text, improving the coherence and relevance of the generated content. Transformers are also highly parallelizable, making them more efficient in training on large datasets. Training generative AI models. Training involves feeding the model large datasets and adjusting its parameters to minimize errors. This process, known as backpropagation, requires substantial computational power and time. The model learns to generate new content by understanding the patterns and structures in the training data. During training, the model is presented with input data and generates predictions. These predictions are compared to the actual data, and the errors are calculated. The model's parameters are then adjusted to minimize these errors, improving its performance over time. This iterative process is repeated many times, with the model gradually learning to generate more accurate and relevant outputs. Inference and generation. Once trained, the model can generate new content. Inference is the process of using the model to produce outputs based on given inputs. For instance, given a prompt, a language model can generate a coherent piece of text. This ability to generate human-like text has numerous applications, from chatbots to automated writing tools. During inference, the model uses the patterns and relationships it learned during training to generate new content. For example, if the model is given a prompt like "once upon a time," it might generate a story that follows this prompt, using its knowledge of language and storytelling to create a coherent and engaging narrative. Fine-tuning and customization. Models can be fine-tuned for specific tasks by training them on domain-specific data. This customization enhances their performance in specialized applications, such as legal document generation or medical report writing. Fine-tuning allows models to adapt to the nuances of specific fields, improving their relevance and accuracy. Fine-tuning involves taking a pre-trained model and training it further on a smaller, specialized dataset. This allows the model to learn the specific patterns and relationships relevant to the target domain, improving its performance on related tasks. Fine-tuning is a powerful technique for adapting general-purpose models to particular applications. Applications in MLOps. MLOps, or machine learning operations, involves deploying and maintaining machine learning models in production environments. Generative AI models can be integrated into MLOps pipelines for continuous improvement and monitoring. This integration ensures that AI models remain practical and up-to-date with new data and changing requirements. MLOps practices include versioning, monitoring, and retraining models as needed. This ensures that AI models perform well in production, even as new data becomes available and requirements change. By integrating generative AI models into MLOps pipelines, organizations can maintain high levels of performance and reliability in their AI systems. This video explored the inner workings of generative AI and LLMs, including neural networks, transformers, and the training process. We also discussed the importance of fine-tuning and customization, and the role of generative AI in MLOps. If you found this explanation helpful, please give us a thumbs up, subscribe to our channel for more insightful content, and share your thoughts and questions in the comments below. We're excited to hear from you and continue this journey of exploration and learning together. Thank you for watching.